Hey everybody. So this is going to be just a really, it should be a very fast video on how to solve an equation that involves one radical. So one, usually it's going to be a square root, but the same thing applies to like a cube root. If you're in college algebra, it's probably just going to be a square root. Okay, so we want to solve this thing, which of course just means solve for x. The first thing that you probably think is, well, how do we do that when one of the x's is sort of trapped under this radical? We can't just split up this radical or do anything like that. We first have to deal with the radical. So how do we deal with the radical? How do we undo the radical? Well, this is a square root. What undoes the square root? Squaring. So let's square both sides. If we square the left-hand side, we get 15 minus 2x. And if we square the right-hand side, it becomes x squared. So now we have a quadratic. And you can choose whatever method you like for solving the quadratic. This one, I believe this one factors, yeah. So rewriting this, I would rewrite this. I prefer to keep the term with the highest power. I prefer to keep that positive, so the x squared term. So what I would like to do is move everything over, but I'll rewrite it this way. So it's going to become x squared plus 2x minus 15 equals 0. And yeah, this does factor without kind of getting into all of the factoring. I have a video for that, so if you are a little rusty on factoring, you might want to go check out the video. It factors to this, x plus 5 times x minus 3, which then gives us the solutions. X equals negative 5 and x equals 3. Great, we got two solutions. But before we go ahead and we box this off and submit it as, submit it to the instructor or whatever and say, yep, I found the solutions, we should quickly double check our solutions, which just means take both of these solutions, plug them into the original problem, and see if they check out. So I'll start with x equals 3. So if I plug in x equals 3 into this original equation, what do I get? It keeps getting unfocused. It's because my hand moves around so much. I need to figure that out. Let's see. All right, so it becomes the square root of 15 minus, well, 2 times 3 is 6, so 15 minus 6. And we're asking, is that equal to? So I'm going to put this little question mark over because I don't know for sure if that equals 3. I'm checking that. And it looks pretty promising because 15 minus 6 is 9. So the square root of 9, and I'm still putting the question mark, but yeah, the square root of 9 is 3. So this is not like the square root property. The square root of 9 is not plus or minus 3. The square root of 9 is just 3. Yeah, cool. X equals 3 is a solution. Great. Now let's check x equals negative 5 and see what happens. So if I plug negative 5 in, well, I'd have square root of 15. 2 times negative 5 is negative 10, so 15 minus negative 10 becomes 15 plus 10. And we're checking, does that equal, x is equal to negative 5, so does that equal negative 5? And if you have a little alarm bell going off right now, that's good. What's happening on the left? Well, 15 plus 10 is 25. Does that equal negative 5? It does not, because the square root of 25 is just positive 5. And positive 5 is not equal to negative 5. So what does that mean? It means that x equals negative 5 is an extraneous solution. Some textbooks will call that an excluded solution. I think extraneous is maybe a little bit more proper. It just means, extraneous just means it's a solution that technically fell out, like we didn't make any illegal moves as far as this algebra goes. It's just that the way that the original problem is stated, there are certain solutions that might fall out from the algebra that don't actually work. And that happens anytime that you do this move right here. It comes from this step right here, squaring both sides. Anytime you're squaring both sides, or same thing like if you have a rational expression and you're multiplying by like a common denominator, Anytime you do that, you might be introducing solutions that aren't actual solutions to the original problem. So yeah, with a problem like this that involves radicals, or if it's a rational, if there's some rational expression in there, you'll want to go back and check your solutions. I mean, in general, you always want to check your solutions. But yeah, with these ones in particular. So the only solution is x equals 3. That's the only one. Okay, so that's everything for this video. 5 minutes, yeah, pretty short. If you have any questions at all, let me know. I'll be happy to answer them.